All right, so we're doing exercise 13A and we're looking at question 6. So let's give this a go. They look kind of tricky, but they're not that tricky. They're just going to take a bit of time. So let's look at A. So what are we doing here in A? So the first thing I'm going to do is bring this 3 inside my brackets. So I'm going to be left with 3, 3. Then now I'm going to be using my third index law to multiply these indices together. So 4 times 3 is 12. Then 3 times 3 is 9, so B, 9. Then I'm going to multiply. Now, what I'm going to do, I could do this several ways. I have a negative indice here, so I could take the reciprocal of this entire thing right now, or I could do it later. I'm just going to do it later. I'm just going to bring this negative 2 inside. So it's going to be 4, negative 2. Then A, now 2 times negative 2 is negative 4. And then B, 4 times negative 2 is negative 8. Now what I'm going to do is, well, 3 cubed is 27. A to the 12, B to the 9, then I'm going to multiply. Now, 4 raised to the negative 2, A raised to the negative 4, everything here has a negative indice, which means what I can do is actually bring it all down into my denominator. So I'm just taking the reciprocal of the entire thing here. So it's going to be 4 squared, 8, 4, and B8. And what I actually might do, instead of writing 4 squared, I'll leave it like that for the time being. I'll do it in my next line of working. And when I say I want to see you working out in your textbook, this is what I mean. This is what I want to see. I want to see what you're actually doing. Because if you just show me the answer, that probably just means you looked in the back of the book. Let's be honest. B9 times, actually instead of doing that times, what I'm going to do is go over. So what, if you can picture this for a moment, this is like being over 1, and I'm timesing that 1 over something. So if I times my numerators together and my denominators together, what I'm going to be left with is this times 1, which is that, and then this times that, which is just this, because anything times 1 is just the number, the other number. So 4 squared is 16, 16, A4, B8, and I'm going to scroll down. Now, there's no number that goes into both 27 and 16, so they actually just stay like that. And now I'm going to have a few more things on my denominator here, because it's going to be, I have an A and an A here, so I know according to my second index law, I can subtract my indices because they have the same base. 12 minus 4 is going to be 8, so I'm going to have 8 here. And then I'm going to have 9 minus 8, because I have B's with the same, obviously I have the same base, B. 9 minus 8 is just 1, so just B by itself. Now, you could write it like this, but it's kind of ugly to write it like that. It looks a bit lopsided. So I'm going to write it like this, 27 over 16, and then I'm just going to write A8 and then B. And that's going to be my answer. So hopefully that makes sense to everyone. Let's now come up and look at B. There we go. Let's have a good look at B now. So how are we going to answer this? All right, so what I'm going to do is bring this 3 inside, and I'm going to have to remember my law 5. So this is kind of like my law 5 tells me that my law 4 and 5 is about products and quotients and about bringing things inside. Hopefully we all remember that. So remember that this 3 also has to come down to my denominator as well. And we have to remember my third index law, which tells me that my indices are going to multiply as well. So there's a lot we have to consider going into this. So this is going to be 5 to the 3, then 3 times 3 is 9. So this is going to be, it's going to be A to the 9. Then I'm going to have B to the 9. Now, as I said, this 3 is also going to come down here. So I'm going to get A3, B, 2 times 3 is 6, and then 2 times 3 is 6 again, so C6. Then I'm going to, now, I have divide this. Now, hopefully we can all appreciate the fact that the same thing, this would be the same as going times the reciprocal of it. So 1 over, and this, and I'm going to bring this 3 into the inside. So I'm going to be left with A, 2 times 3 is 6, B, negative 1 times 3 is negative 3, and then C, 3. All right, let's keep on going. So that was a big step we just did. What I'm now going to do is bring this negative indice up the top, so it will no longer be negative. This is an ugly 3 as well. That's even uglier now. All right, so what I'm going to be left with is, actually, I'm going to do a bit of a cheat step. I'm just going to copy this. Copy this. Let me get rid of that. Paste that down there. Bring this up here. What I'm going to do is I'm going to take this and bring it up here, B3. So it's no longer negative anymore. I might just get rid of those and put them next to each other now. So I'm going to get A6C3. That 6 looks like a B. Perfect. Now I'm going to continue. Now I'm going to use my my first index law, which tells me that when I'm multiplying things with the same base, my indices add together. First of all, 5 raised to the 3 is 125. I have an A here, A9. Now I have a B and a B here, and they're going to plus together their indices. So 9 plus 3 is 12, so it's going to be B12. Then it's going to be divided by, now it's going to be A, and these 3 plus 6 is 9. There's a lot of 9s here. Then I'm going to have B. Now I just have B6, there's no B's on this side, so that's just B. Then I'm going to have C, and I have a C6 here and a C3 there, so it's going to be 9. Now that's going to be equal to something. What's that going to be equal to? That's going to be equal to, now I'm going to have to use my second index law to do some subtraction here. So this, let me do this, 8, 9, 8, 9, so they're obviously just going to go away with each other. And then I'm going to have B6 and B12. Well, 12 minus 6 is just 6, so that's going to go away. And instead of that, I'm going to have 6. So that means what I'm left with is 125 B6 over C9. And that is my final answer. So a few steps there, but hopefully that all made sense into getting to the right answer, which is 125b to the power of 6, c to the power of 9. So we have now answered, let me zoom all the way out, 6, and we answered both of them. I'm just going to do a bit of tidy up now. You can stick around and see what I'm doing. I'm just going to move this over here. And remember, you can refer to the OneNote if you ever want to see the solution without seeing the video, but I'll put the video somewhere as well. All right, that's it. Hopefully this was helpful.